Okay, why don't we make a start? I think we've got a lot of people in, maybe more people will join. Welcome, everybody. My name is Beverley McKeon. I'm one of the co-lead editors along with Eric Lauga. The managing editor of Physical Review Fluids, Brad Rubin, will moderate our event today. So over to you, Brad.
Welcome to our tutorial. And so I will be the moderator of the tutorial. And on the panel, we have Beverley McKeon, who is the lead editor of Physical Review Fluids, and Eric Lauga, who is also a lead editor. We have the associate editors, Howard Stone and Roberto Zenit, who will also answer your questions about the journal. And Matteo Rini, who is the editor of Physics Magazine, will give a presentation about how to write a compelling scientific paper, and we'll answer your questions about that. So we start today with my introduction to the journal, to the PR Fluids Journal, and then the lead editors will discuss some new and other initiatives and give some tips on refereeing. Then there will be a Q&A with the lead and associate editors, followed by Matteo's tutorial, and then your questions once again. So Physical Review Fluids has an editorial staff with 2 lead editors, the manager, which is me, and there are 2 associate editors who edit the letters section. And one of them, Howard Stone, is here today and on the panel. And then there are 15 other associate editors who handle various categories of papers in terms of topics. So the lead editors will mention them again. So go ahead. So Physical Review Fluids began publishing in 2016 when the editors of Physics of Fluids moved to form this new journal here, which APS had agreed to. So it is the only journal in APS which is devoted exclusively to fluid mechanics. It has grown rapidly with about 600 papers expected to be published this year, which will be a 3% increase from last year. The letters section publishes shorter letter styles papers containing especially timely and important new results, and about 40 are expected to be published this year when the year is over. Each month, the editors select 2 to 5 papers of particular interest or importance or clarity as editors' suggestions. Okay. Go ahead. So the criteria for acceptance to Physical Review Fluids, it's important to understand that, of course, we want papers that are scientifically sound, that are not obviously wrong, but it's not enough just to publish something that's correct. You have to have something that advances physics significantly, that is not just incremental or trivial, but is a meaningful advance that looks like something that other people can also build on. And of course, we also want papers that are accessible to readers, that are presented in a way that's easier for people to understand. And of course, Matteo will be talking later about how to write a compelling paper of this nature. Okay. So just as a reminder, the peer review process, you submit your manuscript, of the editors can reject it initially if they find that it doesn't meet the criteria that I just described. If they think that it could meet those criteria, they send it for more detailed review, thorough review to expert referees who are expert in the topic of your paper. Those referees return a report. The editors examine that report, and if the report is informative and tells us something which we think will, advance this process, then it can go, they can make a decision at that point. Based on the first round of reports, we typically send to 2 reviewers. We attempt to get 2 reports, and at that point it could be rejected or accepted, but more likely at that stage the referees have suggestions for the authors. It's sent back to the authors for further revision and consideration, and then that process can repeat until a final decision is made whether to accept or reject a paper after perhaps 1 or more revisions. Okay, but it's ultimately the editor who makes that decision on the advice of the referees. So the referees don't make the final decision, it is the editor. Okay, go ahead. So next, the lead editors will talk a little more about the journal and some upcoming initiatives.
Thank you very much, Brad. I had forgotten to unmute myself. Thank you very much. So Brad gave you the list of all the editors of the journal with their affiliations. We thought it would be useful to also put pictures to people's names. So as Brad mentioned, there are 2 lead editors running the journals, and there are 2 editors for the letters, the short papers in the journal, and the remaining editors, the remaining associate editors, 14 of them, handle the regular submissions to the journals. In addition to editorial staff, associate and lead editors, the journal has a board. The board members play different roles. They help with adjudication of papers where there are conflicting referee reports. They advise the journal on strategic and initiatives. And we thought it would be important to not only show you the current member of the boards, presumably you know already many of them from the fluid dynamics community, but also to highlight the recent appointments to the board. So those are highlighted at the bottom with the orange highlight. And in particular, we want to highlight, in addition to, so the first line are 5 regular board members, but we've also appointed now 3 early career board members, people at the beginning of their academic careers. So junior, typically tenure track assistant professors who have very important basically input on the journal and the way we have initiatives and future ideas for the journal. And the founding editors of the journal, of course, John Kim and Gary Leal, have remained on the journal and are still sitting on the board, and the experience is very valuable for us and for the community. So I would like to take a minute to highlight important aspects of the journal, and in particular, a strong connection with the Division of Fluid Dynamics of the APS. We are an APS journal, and we have a very strong connection with the Fluid Dynamics Division, the DFD. And in particular, we want to highlight 3 tonight. One is the DFD's Francia Franco Award, which is selected from articles published in physical review fluids by people who are within the first 12 years of their academic career. The 2021 winners were Rodolfo Brandauer and Ulrich Schisner from Imperial College London. They recently gave an invited talk for their award at the DFD meeting, a wonderful talk on the motions of droplet. And so if you are an early career scientist, then that is an opportunity that is open to you. And every year there is the DFD. It's not run by the journal, but it's run by the division, has basically a committee that selects the best paper. So that's one connection with the DFD. The second one is the journal, our journal, Physical Review Fluids, publishes invited articles from the DFD award winners and also from the DFD invited speakers. So every year, about 8 talks are invited talks, plenary sessions at the DFD meeting. And typically those are then published, a version of their talks are then published in the journal. And so if you go on the website, I include the link here, there's a collection link on PR Fluids website where we have the invited papers, basically a collection of, well, we just published the one from the previous DFD meeting, the 2020 meeting. So these are the 2021 papers, but also we have the previous collections and they're going to all gather together in a nice single link. The final point I want to emphasize in the relationship with DFD is the Gallery of Fluid Motion, something that is very popular in our community, obviously, with a lot of posters and video submissions every year at the DFD meeting. And the winners, as you might know, every year at the DFD meeting, there is a competition with a jury that awards prize winners for both posters and also videos. And those are then published by the journal. The posters are published in the journal, and the collection of all the winners appear on our website as well. So again, if you go on PR Fluids and you click, and there's a button in the middle that says collection, then you'll be able to access all of those. So we thought it would be important to highlight the points that are specific to our journal. An event I would like to highlight as well is a new thing that happened this year following the change in leadership at the journal is the Journal Club. So the Journal Club is something that is run by APS for many of the APS journals. And we have been keen participants in the Journal Club. We've had 6 events so far in 2021, and we'll have many more in 2022. And those are once a month, basically live discussion with authors of papers, typically research papers. We've also had one on a perspective article on grand challenges in environmental fluid mechanics. And these are typically a mix of presentation by the authors followed by Q&A. And the talks, if you cannot attend the talks live, no worries, because we're all posting them on YouTube. So if you go on the APS YouTube channel right now, you'll see a record of all the talks. So I will encourage you to check them out. And we're looking forward to welcome many of you on the 2022 version of those talks. I would like to highlight also, following the change in editorial leadership, basically the journal has published 3 over the last few months, 3 editorials. The first one was an editorial kind of thanking the founding editors of the journal and putting forward our vision for Beverley and I for the journal, what we would like to accomplish and what we stand for. We have a second editorial that was published by 2 of our associate editors, Michael Brenner and Petros Koumoutsakos, on the specific intersection between machine learning and the fluid mechanics research, what we believe the journal should stand for and what a paper should accomplish in order to be able to be considered a fluids paper. And then finally, very recently, all the editors, lead editors, the journal manager, but also all the associate editors joined effort in celebrating the first 5 years of physical review fluids and putting forward basically a statement, in some sense, a statement of purpose of what our journal stands for and what we would like to accomplish in the future. So I would like now to give the floor to Beverley, who's going to discuss referring tips.
Thank you, Eric and Brad, and again, welcome everyone. Yeah, so as part of the referee tutorial part of this event, we wanted to just go through a few key points about writing a referee report, and then we'll also speak to how you get involved in refereeing for the journal. So when writing a referee report, you receive a paper, you read it. How do you assess or put together your thoughts? And so here are some key questions for you to ask yourself. So the first one is the work novel, interesting, and original? Sometimes that's very clear. Sometimes you need to go down to the next level, say, is this a significant advance, or is this really an incremental advance relative to other work? And then is it likely to spur work by other researchers in your field or outside of the field, in fact? So that's an interesting sort of first question. Is this, we're really asking about, is this a good fit for the goals of the journal, which are to give some significant advance? The next point is the work valid and reproducible? So that's key, right? The work has to be scientifically solid. Associated with that is, are there enough details provided in the study so that it could be reproduced? So the paper should stand alone in terms of the details that are offered. And as a referee, you can comment on that, whether that's sufficient or not. We want to steer away from unsupported claims. So the paper must give enough information to support any statements or conclusions that are made. And then this last one is about the presentation of the work. So, sometimes papers have beautiful figures, or sometimes they have ones that are less well designed to communicate the message. Sometimes the text can be written better than others. And so as a referee, you are able to comment on that, really about how to improve how the paper is received and read, or the impact that it will make. And so one specific question there is, are there sufficient references that put this work in the bigger context? So it's very rare that a piece of work occurs in complete isolation, so it's appropriate to reference the work that sets the scene around it. Next slide, please. So how to write a referee report? There's no real right or wrong way in terms of a checklist, but here are some useful pointers to that. It's very helpful for the editors who read this for you to summarize what you saw as the key points of the paper, the content. What is it that's novel about the work that you're reading? Then you make a recommendation, and that recommendation can range from accept as is, and you don't need to see the paper again to reject at that stage of your first review, but you have to support that. So why are you making that recommendation? So that's where you really get into the details of what you agree with or disagree with in terms of what's written in the paper. Third is to suggest ways to improve the paper. So that is sort of a part of number 2, in the sense of if you have a concern, you hope the authors will address that. But also just general organizational or organizational comments or additional references that might help support this. You get to help the authors to improve their paper. You don't have to invest a lot of time in terms of spiffing up the whole thing, but there are certainly things that you would see as a reader that could help with the quality of the paper. And the final one is really sort of the important one. I alluded to it in number 1. You have to go back to the journal's acceptance criteria to say, is this a significant change in our understanding of fluid physics? So this is not a journal that is solely dedicated to techniques. That comes up especially with regards to machine learning. So there must be some element of discovery associated with papers that are to be accepted for the journal. So that's a short summary of the type of content that makes for a good referee report. That's the sort of thing you start out with for a first review. If the paper comes back to you after a revision, you get to cross-check against the things that you recommended before and see whether the authors have either implemented them or rebutted your comment. Next slide, please. Just a note here, if you're asked to referee and you're unable to, it happens to all of us, it's very helpful to just decline. If we don't hear from you, we're ever hopeful that you will submit a review, but not hearing from you can slow the process down for your colleagues. So if you receive an invitation to review that you can't accept, we'd appreciate that you decline. We contact you to remind you if you have accepted a review. Again, if for some reason you can't take it on, please do let us know. You can let us know if you're unavailable for a period of time and need a break. You're also very welcome to suggest other referees who might be able to take on that task and also recommend new ones for the journal. We'd appreciate that. This last point perhaps is the most important one for this setting, which is that it's a really interesting professional development opportunity for more senior researchers to write a joint report with a student or a postdoc. So it's an opportunity to give some training or receive some training, depending on which side of that equation you're on. And we encourage that. So we encourage that a senior faculty member writes that report with a junior student, so they learn how to write an effective review and eventually, hopefully, become an independent reviewer for us as well. Next slide, please. So speaking to that, we would like to hear from you if you'd like to join the refereeing pool for physical review fluids. This statement at the top here, refereeing is a responsibility that comes with being part of a scientific community, is really meant to reflect that if you're publishing papers, then 2 or 3 members of the community are reviewing each of those. And so similarly, you should be reviewing a certain number of papers yourself. It's a very good way to learn what's going on in the field, to learn how to improve your own writing by seeing what other people do and how the revision process works. So we are looking to increase our reviewer database. So if you're interested in joining the physical review fluids referee pool, please, or physical review referee pool, please send a message to help@aps.org. What we do when we evaluate those applications is look for, I'm sorry, not the application, when we're looking for referees for a specific paper, we're looking at the publication record in APS journals. So are you active in the fields where our journals are publishing? Do you have a current role in research? And I've spoken to the grad students already. It's useful for us to know your expertise, where you would like to receive papers, what type of topic. And please do keep your expertise and contact information up to date so that we can reach you when we have an invitation for you. But the message here really is that we invite you to be a part of the journal. I guess at this point, I'll turn this back to Brad and I think we open up for Q&A, correct?
Yes, so if you have a question about refereeing or about the review process or other things that we've the journal that we've discussed, you can please type it into the chat box, and you can
you can also type in an area that you'd like us to expand upon, or if you'd like to hear maybe one of the associate editors' opinions on that too.
So maybe you could talk while we're waiting for questions, could talk a little bit about how people can respond to referee reports, especially when they when it's maybe not a favorable report.
Can we bring in the associate editors, Howard and Roberto? Would you like to add anything on the reviewing or responding side?
I can answer Brad's suggested question. Yes, I think it's very important that to take the comments from the referees in a serious way. One thing that I learned from my PhD supervisor is that if the referee is asking you a question, is because you were not sufficiently clear in conveying your message in your paper. It's not always the referee trying to put you down or to be negative or critical about your paper. So you need to take this responsibility to write the paper in such a way that is the clearest possible. So if the referee asks a question, even if it's a negative or a critical comment on your paper, you should strive to make your writing more clear, more precise, and I find that to be very, very useful in the writing of a paper. You have to use your language skills in the best possible way, because again, your work is good. It's your intellectual result, the thing that you did for research. So many times is the way you write it, you present it, that may appear incorrect or something that can be criticized by a referee. So I would just take the best possible spin on a negative report.
All right, thank you, Roberto. We do have a question here. Can you please expand on what is meant by incremental progress? An example would help. So
maybe I can I can give an example. So in my specific research area in biological fluid mechanics, we have a lot of the theoretical research is based using numerical simulations. And an example to me of an incremental progress is our studies that kind of reproduce past work and just change a little bit the parameters, the range of parameters. We see this again and again on papers that basically have a larger range for a parameter, but don't bring forward new ideas, new modeling ideas. They're just doing a little bit more And so that would be an example, in my opinion, of incremental progress. Perhaps Howard or Roberto, you have something else you want to say?
Well, I mean, I think that's a very nice example, but I mean, obviously you want to be able to articulate clearly why something you've learned is new and interesting. Now, interesting is an awkward word because interesting to one person might not be interesting to another person, but you want to be able to say, at least to yourself, that it's a result in fluid mechanics that will be useful to someone in some way, as a researcher, as a teacher, as an educator. And normally, if you can say that, then I think you have a argument for why it's not just incremental. But there is a bit of, as you'll see when you go through your career of writing papers and getting reports, there is ambiguity in the way people evaluate papers. And if I can sneak in one more thing, the only thing I wanted to add to Roberto's wonderful, great answer was that many times when we answer the referee, we put in some information. Sometimes we put in a graph figure. My own feeling is that the referees are model readers or example readers. So if they have the question, just like Roberto said, other people are going to have the question. And if you think to answer the question, you have to put in a figure to help explain it. You might want to think about whether you should now include that in your paper, because other people are going to ask the same question, because no one ever sees the referees' reports, at least the way the journals are structured right now. Okay, I'll be quiet.
Thank you, Howard and Eric. We have another question. If the paper is submitted from a non-native speaker, how tolerable are you with regard to English? Beverley?
Maybe I can take that one. I think what's really important is that you're able to communicate your ideas in a way that the audience and the reviewers can read it. And so it's certainly worthwhile investing in a proofread before submitting. That's not something that we do at the journal level. We would reject a paper if the ideas were not communicated sufficiently clearly for an English or non-English speaker to read. So it's about getting the message across. So there is a proofreading, or there are proofs generated before publishing, but we do not offer a proofreading service to deal with the English in the article.
Okay. Another question is, there are several journals devoted to fluids. Does PR Fluids emphasize certain areas of fluid research?
I can briefly perhaps answer this. I see the next question is on letters, so the next question will be very appropriate, I guess, for Howard. PR Fluids does not emphasize certain areas of research. No, we are very proud to be very open and to publish fundamental advances in all areas of fluid mechanics, from turbulence to geophysical to microfluidics to granular to non-Newtonian. And basically, we are not prescribing anything about the particular part of the fluid mechanics community that we want to publish. We want to publish fundamental advances and new physics within those areas, whatever those areas are. And so it's very important for all of you who perhaps have not, some of you have not published in the journal, to realize that we publish all of fluid mechanics, in all of fluid mechanics. The next question I see, I'll just maybe ask Howard, because Howard is the editor, one of the two editors for letters, to perhaps, if you wouldn't mind speaking for a minute between the difference.
I'll keep it very short.
Letters.
Yeah, I'll keep it very short. So the first thing, if you're thinking about submitting a paper to Physical Review Fluids, if the paper is shorter than a certain length, which generally means then that the idea is compact, then it may qualify for a letter. There's a length restriction on letters. Most importantly, it has to have an important idea in it that is recognizable. But it is also true that because it's a physical review journal, that at least half of the letters we publish have started out in physical review letters. Now, by being submitted there. Now, some of them, the editors of physical review letters who are distinct from us, they might not see it as relevant to physics more generally. They might see it as occupying a narrow regime of just interest to the fluid mechanics community, and they will probably not even then have it refereed for physical review letters, and they will then give you the option to transfer it to physical review fluids. And other times, papers will be refereed for physical review letters, and some of the referees will argue, perhaps convincingly, that it's too narrow for the broad spectrum of the more general physicists, and then the paper will get transferred to physical review fluids. So, you know, there's a bit of ambiguity in that, and trust me, all of us have had papers turned down for physical review letters because it was viewed by our colleagues as too narrow for the general physics community. But we're pleased to welcome them to physical review fluids if it has an idea that is important to our field.
All right, thank you, Howard. There's one more question I think can be answered quickly, and then we'll move on to Matteo.
Can I do that maybe while Matteo sets up his slides, just so that we can hand over? So the question is, how often should an experienced reviewer review in, for example, I guess numbers or a month? I mean, I think the key thing to keep in mind here is that every time you submit a paper, again, you're asking that 2 or 3 of your colleagues review it for you. And so that's the sort of number to have in mind. You should be at least covering the work that you're generating for others in the field. Practically, we are able to check and ensure that we're not sending multiple requests to a single reviewer from physical review fluids, but of course we can't check that across journals. But that's a rule of thumb. Some people are very kind and do more reviewing work than that. Some people turn down any reviews, but that of course is not conducive to publishing as an academic endeavor. So hopefully that's a quick response, and we'll hand over to Matteo.
Thank you, Beverly. Can you hear me well?
Yes.
Great. Thank you. Thank you, everybody. It's a great pleasure to be here. I'm really a big fan of the physics of fluid, and we cover it a lot in our physics magazine. So I usually give this kind of tutorials about writing. I've been a science communicator for about 10 years now. We only have 20 minutes today, so I hope I can at least share some principles and ideas. I am the editor of Physics Magazine, which is a sort of a popular magazine by the APS, where we highlight the best results that we publish, but we also do more. I'll spend a couple of words on that. But I also teach science writing and communication at New York University, and I give a class there on how to publish high impact papers. So given the time, I'd like to start with the take-home message, and if that's the only thing you want to retain from this talk, I think this is an important one. And this is this belief that I have that as a scientist, you have to consider yourself a professional writer, or if you want to put it broadly, a professional communicator. I worked about 10 years in active science. I worked for 5 years as a consultant to politicians, and now I work for 10 years as a communicator. I met many scientists in my path. And I know that they're ready to do a lot of things for their work. They're ready to, spend months learning a new language, aligning a new laser, trying to work and operate with a new instrument. But very few of them think about writing as a sort of an active part of their duty, in which they have to work as professionally as they do with other parts of their science. And I think this is a mistake, and I'm not arguing for scientists to take classes, to go to a particular workshop or anything like this, but simply to accept this responsibility, take it as an integral part of your work, and then every time you're doing it, to think a little bit on how you're doing it. And if you do it consistently, you will slowly improve, you will develop skills, and your writing will have more of your voice and will be more effective. A lot of people, when I give these seminars, they think that writing well is one main purpose, and that is publishing more. But I would argue there are many more compelling reasons to write well. The first one is to be cited, and I read hundreds, if not thousands, of papers every year, and I can tell you that the most cited papers are the ones that communicate well their findings. So obviously, citation metrics are a very important way of quantifying your productivity as a scientist. So if you want to get cited, your papers have to be understood by people, maybe from neighboring fields, maybe from other fields, and so on and so forth. A second reason why I think writing well is very important is that the way I see science going these days is that a lot of the breakthroughs to come will come from the cross-fertilization of ideas across different fields. And this can only happen if papers are written in a way that some people in another field can sort of get the main message of your paper, even though they're not in that field. And I can think of many examples from the physics of fluids, turbulence and some connection to renormalization group theories or ideas taken from particle physics. There are many parts of the physics of fluid where you could certainly make use of ideas from other disciplines. So only if papers are written in a particular way, we can facilitate that exchange. And I think this exchange will be key to many of the breakthroughs to come in all fields of physics. And finally, I don't know the background of the people who are assisting or who are present today, but even if you're a PhD student and you have no idea what you're going to do next, maybe after your PhD, if you learn communication skills, it will be something that will accompany you through your career. It will be very useful no matter what you decide to do. Actually, when I proposed my class at NYU, the biggest supporter there was somebody who also worked for Google, and they said, this is probably one of the most important things that we want students to know when they get out of school. Again, I remind you, I encourage you to consider writing and communicating an integral part of your career and spend some thoughts on how to improve that. And hopefully I will share some of the ideas in this talk that can help you in doing that. As I told you, I'm the editor of Physics magazine. It's open access. You can find it there. There we basically highlight the best papers that we publish. Things like this is the famous discovery of gravitational wave by Lauga in 2016. So the big stuff, but also some of the curious, fun, intriguing stuff. And we cover fluids a lot. The physics of fluid has a lot of newsworthy aspects, good images, good video, connections to everyday life. So we really cover it very, very frequently. But we're not just covering our own papers, and we have many different sections. We are experimenting with different formats of communication. For instance, I don't know if you probably have heard of this result yesterday. NASA sent a spacecraft to the sun, and basically they touched the sun's atmosphere. We had a great cartoon by PhD Comics that explains in a very accessible way what it meant. We have opinion sections, we have interviews with scientists. So we really have a number of ways to present science and to connect to the scientific community, to allow scientists to present their opinion in our journal. So I'd like to mention two aspects of my everyday work for physics. And the first one is that we have to find the best science. And I can tell you more details on how we find these papers that we highlight, but in essence, it implies reading a lot of papers, hundreds of papers, and asking for questions for every paper that we are analyzing. We became really efficient readers of these papers. And I would say these questions are, why you're doing this research, what's your holy grail, what's the big dream results that you hope to achieve. Second, the more specific open questions, what are the specific research needs that you're trying to solve with your work? Then the key result, what is really new, what's a new piece of information beyond what's known before. And finally, the implication of your results. And you would be surprised at how often a paper does not communicate some of these questions, in particular, the impact. A lot of people dedicate their paper to just telling the readers what they've done, what kind of experiments, what results, but they don't tell them the so what. We've learned this, we've achieved this measurement, we have built this device. So what's happening next for fundamental science? What's happening next for applications? So I think this is a very important part of a paper that is very, very often neglected. And the other part of my aspect is I work with many, many scientists, and I try to help them in writing articles that are. So our goal is to make them accessible to any physicist. So I've edited hundreds of scientists from all levels, young postdocs to Nobel Prize winners. It's a very lively editorial exchange. Usually it does very well and people appreciate that, but there are some resistances, and I'm going to show you some exceptions, some uncommon resistance. I want to say that this is what happens every time, but some of the emails that I receive when I'm trying to sort of simplify or make some writing more accessible. The first scientist says, you're simplifying too much, they will think I'm stupid. The second says, if a scientist does not know what a Lyapunov exponent is, he and you should just go back to school. And the third just says, you massacre my text. There is no way to explain this without Hamiltonian equations. So that's kind of responses, I think, exemplifies some of the challenges that are inherent in writing about science. And I think the main one is connected to the environment where we work, to the academic environment. And this is what I lived when I was a PhD student and a postdoc. The chances that I had to present my work essentially consist in talking to my supervisor, some of my competitors, my colleagues. And what's the problem there is that we're talking to somebody who already knows. So we use all the jargon. We're talking to impress our supervisor. We're talking to be evaluated by them. And we spend a lot of time communicating the how we did the experiment, how many hours we spent in the lab. And the second challenge, probably connected, the person who says that if you don't know what a Lyapunov exponent is what I call the curse of knowledge. You've worked on something for many years, and you sort of forgot how it was before you learn all the things that helped you in your career. So you have to sort of make an effort to fight this curse of knowledge and remember the kind of things that people maybe from a neighboring field, kind of words that you are not allowed to use, otherwise you lose their attention. And finally, and I think that this is the central point, is the fact that you are, this people were not relating to the audience. So when they were writing, the only person they had in mind as an audience was their competitor, essentially. But you have to be very realistic about who's going to read your papers, who's going to listen to your talk, and you have to develop an empathy for this audience. So try to get a good representation of the people who are going to read your papers, so the people who are going to listen to your talk, and then relate to them and present your material in a way that connects to them. So in the second half of my talk, I will talk about some ideas on how to overcome these challenges, but some principles are exactly this ones, like, first of all, write with the real reader in mind. So not with your supervisor in mind, not with your competitor in mind, but with the hundreds of people who will read your paper. So there will be physicists from other fields, there will be physicists from neighboring fields. It will also be your competitors, but that's a very limited subset of people reading your paper. So you have to design your paper so that it speaks to all of them. Practice is very important. A lot of people think you're either born a writer or speaker or you'll never make it. I would argue, and I've seen this, that clear and effective writing communication skills can be learned if you pay attention to them. So if every time you're doing that, you try to improve a little bit, you try to reflect on how you're doing this, you can definitely improve. This applies especially to talks. I remember when I was doing a PhD, giving a talk meant staying up the night before the conference and just putting together 10 slides because you had 10 minutes and basically zero practice. I don't think this is an approach that leads to any improvement. So think about that, practice in time. Reading is a very important aspect. You want to, if you look at the most famous writers of fiction, they've read everything that's been published before them. So if you want to become a good writer, you have to be a good reader. So try to read a lot, read from other fields, read from your field. If you encounter a paper that speaks to you, that you find accessible, try to learn the tricks. What did they do to make it that way? And finally, a word of encouragement for those of you who are not native English speakers like me. I realized very quickly when I started doing this job that there is zero correlation between speaking English well and writing well. So writing a good paper is not about not making grammar mistakes. It's about making a logical point. It's about explaining clearly. It's about having a clear line of thought. And so the grammar errors you can fix, but writing a good paper is much more than not making mistakes. So in the next part, I will describe and go through quickly because we have little time, the stages of writing that we usually follow when we're working with a scientist and we're trying to guide the writing of a paper it's accessible to every scientist. So you can think of, if you want, a Nature or Science or Physical Review latest paper that in principle should be readable by anybody in that, any scientist or at least any physicist. And that's a sort of a structure approach that we follow. The first is find your story, build a story structure, and then find the best language for the story. And let me explain a little bit about this. The first one is finding your story. And this is a point that when I usually talk about this, I get a lot of resistance. It's as if storytelling is telling a fictional story. It's losing objectivity. But I strongly believe that when we're writing a paper, we're trying to tell a story. And what do I mean by that? We're trying to tell the story of why we embarked in that research, what motivated us to do a certain type of experiments, how do we read the data that we took, and what are the implications of the data that we took. So I really want to contrast that with just presenting the result. And I think that's the most common mistake in all the papers I read. There are a lot of papers that just present the results that the authors obtained without giving context, without explaining what is new compared to previous research, and without spending any word on the so what and what these results mean for the future of science. Also, if you have a story very clearly in your mind, this will help you a lot in selecting the results and the experiments that are really necessary to tell your story. And I'm also a firm believer that every paper should focus on one main story. And I see this, I think it's an error, I don't know, maybe some people would disagree with me, but when I read some of the cover letters that we receive and scientists are arguing for a number of reasons to publish a certain paper, and they give 6, 7, 8 reasons. We demonstrated this and we developed this device, but this is also the first demonstration of this efficiency. And there are so many elements that make this story publishable. And I can tell you, the additive property doesn't work there. If none of these stories individually is worth publishing, the editors will not be inclined to publish your paper. So it's not that you're adding more reasons for them to publish. So you should focus on one story and build your paper around the one story that you think is the most important, the gist of the paper, the story that you want to tell. And it should be something that you could ideally summarize in a couple of sentences. These are some examples of a story summary, just to have that if you ask somebody and you meet them on an elevator, what is your paper about? And you just have 30 seconds, find 2 sentences to describe the story around which you're building your paper. This is an example with memory for light. The solid state optical memory stores a light pulse and even a full image for more than 1 minute, the longest light storage time reported in a system to date. And once you have that story in your mind, that will help you, that will guide the selection of the elements of the experiments that you really need to substantiate your conclusions. The second part is to build a story structure. You have focus on your story. I think in the first point, it goes a lot brainstorming. You're not even starting to write. And then you devise a structure that tells your story. And there are, many possibilities there. It can be very different depending on what you're trying to do. But I would say that a very useful structure for a scientific paper is this traditional one. You start with a context, the broad why, what's the purpose of the research, and then you go to the research needs, the specific why, the open question that you're really answering, or at least trying to answer a bit in your paper, and then the new thing, what you didn't find, and remember to talk about the implications, the so what. So I would say, with few exceptions, this is a structure that works for most papers and even research proposals. But I think the important thing is that you make a conscious and rational decision about the structure that you want to use. You analyze your paper structure, and a very good tool is to use an outline that accompanies your paper, even if this won't be part of your paper, of your actual paper. It will guide the writing, and I think it will help you analyze your paper, find the redundancies, find things that have been, find logical problems, maybe some paragraphs that are not connected well. And one really important thing that I find in papers, they are paragraphs. In the structure of the papers, paragraphs are sort of the atomic unit, the unit of thought, the unit of composition. And I think that each paragraph should tell a little mini story, a complete story. And some people just write paragraphs and then they say, okay, if it's long enough, we pass on to the next paragraph. But I think the idea is not that. The idea is that each paragraph should give a little message. And a great tool to improve your paragraphs is to give that message very clearly. And there are two important options there. I'll show you one. Point first paragraphs, or paragraphs like this. This is a paragraph taken from one of Lauga's papers. And it starts with a sentence that basically summarizes what comes next. It says the basic features of this is the event, how they call the merger of these two black holes, pointed to be produced by the coalescence of two black holes. So that's the focal sentence. It gives you already the summary of this paragraph. And then what comes next are arguments for claiming that first sentence. So by using that first sentence, you guide the reader, you help them digest all the technical details and information that comes next. And then the third aspect is to find the best language for the story and apply effective writing strategies. And I'll go quickly through this. I'll give you some resources. I think this is a great paper that you can download. It's a style guide from Reviewed Modern Physics. There are some great tips there and a lot of examples. They have a specific section for non-native speaker. I think it's really worth consulting if you're writing papers. And going quickly through some ideas and principles. Quickness and lightness. Again, you don't have to speak in a stuffy manner for a judgmental audience composed of just your supervisor or just your competitors. Try to be as simple as possible, as everyday as possible. Economy is a very important part. This is a quote from a great teacher of writing. The secret of good writing is strip every sentence to its cleanest components. So every word that doesn't need to be there 100%, you need to cut it. And the shorter your paper, the more compelling it will be. We have this principle in science, Occam's razor. If you have a simple theory that explains the data, you have to choose it over a more complex theory. And I think the same applies to writing. The simpler writing is the one that you should choose. And towards the end of my talk, let me give you just a few ideas on some of the things that I find regarding quickness and lightness. Some things. This is some example that I'm encountering a lot these days. People are studying the migration of birds and thinking that it's connected to quantum mechanics. And I'm handling these papers a lot, and a lot of them, they cannot say birds when they are talking about birds. They want to sound scientific and academic, so they want to write avian species. And it really confused me in the beginning. I even thought, are they not the same thing? Are there some birds that are not part of the avian species or vice versa? No, the only reason is that these people want to sound academic and complex and scientific, so they prefer to use 3 complex words as opposed to 1 everyday word. And I just go quickly through this. There are many, many other things. Recognizing and cutting any form of clutter. This is a sentence that I typically encounter in the conclusion of a paper. This work sheds new light on the physics of nuclear fusion. In that position in the paper, that sentence doesn't tell you very much. Basically, it's telling you this word tells you something new on the physics of something that you know this paper is about. So if you want to say something new, then say, what is this new light? But the word, the sentence in itself, it's not very useful. And other tricks, adverbs are often not very needed. If you are conclusively demonstrating something, you're demonstrating it. So try to find different ways of cutting, of selecting what's really essential. Just a note on active and passive voicing. A lot of people tend to use passive voices a lot. Active is more engaging, is shorter, and doesn't leave an open question who did it. And so in general, one has to favor active voicing, but this is sort of a detail. So I think my time is basically over. So I just like to wrap up with some other principles that I think should inform your writing, and I will also give you some resources. One important one is visibility. Figures are a very important part of your paper. You work on the physics of fluid, you know that. So a very good tip when you're building your paper is to build it around the figures. Try to read the figures and the caption independently. Analyze your paper. Think you're doing a presentation using them as slides. Do they tell a clear and coherent story? If not, you should work on them. The other is what I call multiplicity. I told you you're not writing for your competitors, but you are also writing for them. but there are ways to design your paper so they can have multiple points of access, multiple experiences that you can connect to. And so try to analyze your paper in this way, so you will have an abstract and an introduction that are possibly accessible to every researcher. And then the next paragraphs may be accessible to researchers in a related field. And finally, you have the core of your paper that's really focused on researchers in the field. And a very good metaphor is to give your paper an hourglass structure. It starts very broad, you're speaking to everybody. Then it becomes narrow, you're just talking to the expert. But then remember to broaden it up at the end and to connect again to everybody who might be looking at the implications of your paper. So I think this is a very good metaphor to describe this multiplicity sort of idea. So I'm concluding now, and I'd just like to summarize this principle. I know, this has been a very quick talk, so feel free to write to me with any questions or ask questions now. These are 6 principles that I think apply for the writing of scientific paper. They are taken from a series of lectures that a famous writer from my home country was supposed to give in Harvard. He didn't give them. He died on the way there. But he was summarizing 6 principles for the writer for the next millennium. And I think they resonate very well with what I'm trying to say. Lightness and quickness. Your paper shouldn't be stuffy, it should be as simple as possible. There is no value in saying avian species if you can say bird. Quickness, let's try to recognize any form of clutter. Delete everything that's not absolutely necessary. Exactitude refers to the structure of your paper. It has to be perfectly in a logical way. It has to be an algorithm that convinces the reader of your conclusions. Visibility, figures are very important. Try to use them well, build your paper around them. Multiplicity, try to design your paper so that it can be accessed by a multiplicity of people, and think of it as an hourglass. And the final memo that Calvino was going to write was about consistency. He died before writing it, so I don't know what he was going to say. But let me reiterate what I said in my first slide. I'm really convinced that if you're a scientist, you're a professional writer. And so if you take on this responsibility as an integral part of your work, if you do it consistently, you are writing very often emails, briefings, reports, papers, grant proposals. And if every time you're doing that, you think about how you're doing that, and you try to improve it, you try to learn by reading, this consistency will very soon lead to improvement. So very slowly, you will essentially find that your writing speaks like you, as your own voice. It has the clarity of your thinking, and it has the passion that drives your research. And so if you spend some time working on this aspect, it'll become easier, become more efficient, and become more fun for sure. And let me just give you, this is my email. I think this is a great book, and it's my favorite. I think every physicist should read it. It's a bit outdated, but the title is very compelling. How to write papers that get cited and proposals that get funded. It's a very philosophical book. It's not going to tell you a lot of details and grammar tricks and things like this. I would complement this with the other article that I cited before from Review of Modern Physics, that appendix. And the two together, I think, are very valuable resources if you want to improve your writing. So with this, I thank you for your attention, and I'll take any questions. Thank you so much for being here.
Thank you, Matteo. And you can start with someone is interested in, wants to know if you would share your slides. Perhaps if they wrote to you privately, would that be a way? Or?
Sure, just send me an email. I'll write my email in the text box here. Or you can also write to the editors that you know of PL Fluids, and they will forward the request to me.
And another question, someone congratulates you on the excellent presentation, and then asked, do you recommend beginning the writing process prior to having concrete results or story?
I do recommend doing a lot of brainstorming before starting to write, and that could imply even starting to write before you have all the elements, because as you're trying to put down your thoughts, you're trying to think about that thing that I call the story that you want to tell. And so I think that could be a useful guidance. So you may do new experiments, you may analyze your data differently. A lot of times analyzing data leads to finding some outliers that could give you some hints on how to completely redefine your research. I think that the main point I want to make is that you don't have to think, okay, I've done all the experiments that could, I sit down and write my paper. A lot of brainstorming beforehand is very useful. Even if your experiments, your calculations are done, do not start by writing. Sit down, accumulate material, jot down some notes, and do some brainstorming, and especially think about what is the central message that you want to give around which you're going to build your paper.
Okay, thank you very much. And with that, I think we're ready to close the session. So I thank everybody for coming and participating. And let's thank our panel as well. And we look forward to hearing to getting your hopefully well-written papers. All right, thank you.
Thank you, everyone.
Thank you,
Thank
Howard
you.
and Brad and Matteo and Roberto.
Thank you. Bye-bye.
Thank you. Bye.
Oh, I said happy holidays, everybody.
Thank you. We'll wait for your papers to be submitted to physical review.
Goodbye.